So it turns out that one of the question types that shows up most often on the IB exam are questions about quadratic functions, or questions about parabolas. And so this video and the few that will follow it are designed to help remind you of all the things that you've already learned about parabolas. You did a lot of work with parabolas in algebra and intermediate algebra and even in math analysis, so we really just need to retain some of that knowledge. So the first thing I want to remind you of is I want to remind you of the three most common forms of quadratic functions. The first was standard form, which was always written as y equals ax squared plus bx plus c. The next was vertex form, which was y equals a times x minus h squared plus k. And the last was intercept form, or you might have learned it as factored form, which was y equals a times a first factor times a second factor. We can look at some examples of these things later, but these effectively were the three common forms for quadratic functions. A lot of times they'd be given to you in this form. In order to get to this form, you usually used completing the square, and in order to get to this form, we would basically do factoring. So the next component of this first slide that I want to talk about are parabolas, right? So these first things are quadratic functions. They're functions that have an x squared term in them. Or rather where x squared is the highest power of x. These next things are sort of features of a parabola. So all of the graphs of these are parabolas. And in my mind, there are really three key pieces of information about a parabola. There's the y-intercept of the parabola, there's the vertex of the parabola, and there are the x-intercepts of the parabola. And what's sort of neat, even about how I have this stuff organized, is that the values of each of these different forms are effectively how easy it is to get these things. And so if I just pick up these key features and put them here, what I had intended to show you by this first slide is that in my mind, the main reason for the standard, the biggest benefit out of the standard form is that it's incredibly easy to get the y-intercept. The main value of the vertex form is how easy it is to get the vertex. And the easiest thing for us to get out of intercept form are what the x-intercepts are. So in the next three slides, I want to remind you briefly about what to do with each of these forms, about what can be done with them. From there, we'll go into some other videos that I'm intending to just sort of make examples of the sorts of things that we can do. So when we are in standard form, the y equals ax squared plus bx plus c, be aware that the a, the leading coefficient, is really important. And it's this first line here is going to be exactly the same for the other two forms as well. A determines the direction of the graph. If a is greater than 0, the parabola is opening upward. If a is less than 0, the parabola is opening downward. You guys may also know that if the absolute value of a, the bigger that a is, the sort of steeper and more narrow the parabola is. And if that a value is a small fraction, it's going to end up being a wide open parabola. So then the notable feature about standard form is that the y-intercept is 0, c. Whatever number is added or subtracted here at the end, whatever constant is on the end, that's the y-intercept. Standard form makes it very, very easy to figure out what the y-intercept is. Now, the x-coordinate of the vertex, or the vertex, you can get there, but it's not as easy in standard form. If you want to find the vertex from standard form, you're going to have to use this. There was this little formula, x equals negative b over 2a. And if we take our b and our a values and we use this little formula, it'll give us the x-coordinate. From there, we can take our function and evaluate using this, so plug in that value for x, and we can find out what the y-coordinate of the vertex is. Similarly, the x-intercepts can be found, but they're not as easy in standard form. To do it, you set y equal to 0, and then solve the quadratic equation, which either requires factoring, or the quadratic formula, or completing the square. It actually probably takes the most work to get the x-intercepts out of standard form, but it can be done. Okay, so that's the 2-minute overview of what standard form is about. Next up is vertex form, one of my personal favorites. So vertex form looks like this. It's where a has sort of been factored out. We have x minus h squared and then plus k at the end. Generally speaking, the way that people get to vertex form is they take standard form and do completing the square on it. There are some other methods, but that's sort of the key way to get to it. We might do some examples of that later. So notable features. Just like I said before, that value of a determines the direction and shape of the graph. If a is greater than 0, it opens upward. If a is less than 0, it opens downward. And if the value of a is very large, so if that's 5 or negative 13, you're going to get a very steep parabola, either up or down. And if it's a fractional value, if it's sort of a small less than 1 value, like a half, you'll either have a wide open parabola opening upward or a wide parabola opening downward. The reason it's called vertex form is that it's so easy to get the vertex of the parabola. The vertex of the parabola is simply h, comma, k. Right? We take that to be the opposite of the value that's added next to the x, and then the value that's added or subtracted on the end. So if you've got it in vertex form, the vertex of the parabola is very, very, very easy to get. The y-intercept and x-intercepts can be found, but they do take a little bit more work. So the way that we find the y-intercept is sort of the way we should do it for any function, I suppose. To find the y-intercept, we solve for y when x is equal to 0. And that should make a lot of sense, right? I mean, if you have any shape and you want to know what the y-intercept is, we should evaluate it when x equals 0, right? Similarly, if you want to find the x-intercepts, we find the x-intercepts by solving for x when y is equal to 0. So we set y equal to 0, and that sort of helps us to identify what these 2 points are. You'll notice that finding the x-intercepts in vertex form is a lot easier than it was in standard form. Once we've set y equal to 0, we can move the k over, divide by a, take the square root, and solve. We really don't need to do anything fancy. It's sort of the same method each time. So that's the 2-minute version of vertex form, what it's easily used for, and what it can be used for. Last to the party is intercept form. Intercept form is effectively what happens when you take standard form and factor it, right? So the notable features of this one, I don't even want to mention this top one because I've already said it 2 times before. A determines the direction of the graph. This A is the exact same A that we used in vertex form and standard form. There's a reason I left it A throughout, because it doesn't matter what form you're in, that A is always going to be the same value. It's always A. In intercept form, the easiest thing to find are the x-intercepts, right? If you were to set y equal to 0, you would immediately have these 2 things equaling 0, which tells you that your x-intercepts are m and n. So we get m comma 0 and n comma 0. Those are automatically your x-intercepts. Intercepts are very, very easy to find in intercept form. Finding the y-intercept, it's not hard, but we do have to do a little bit of work. We solve for y when x is equal to 0. So we evaluate this thing when x is equal to 0. That'll give us our y-intercept. Finding the x-coordinate of the vertex is an interesting thing to do here. Suppose that you have a parabola that's sort of sitting like this, right? And let's say that, just for the sake of argument, let's say this is 1 and this is 5, right? If I were to ask you what is the x-coordinate of the vertex, the reality is because a parabola is symmetric across its axis of symmetry, my vertex absolutely has to be halfway in between the 2 vertices, or I'm sorry, between the 2 x-intercepts. So if we know that the 2 x-intercepts are m and n, we can simply average those 2 x-intercepts together, and whatever that x value is, that has to be the x-coordinate of the vertex. Now the reality is, we have all spent, upwards of a month or 2 of our mathematical history over the last 3 years learning about parabolas. You spent a lot of time on this in algebra and in intermediate algebra, again in math analysis. I'm sure some time was spent on it in geometry. We don't have time, and I don't want to spend another month on it here. So what I'm going to do now is I'm going to look at a couple of extended problems that are taken from past IB exams, and we're going to sort of look at those problems and just look at how we can move between these forms and how we can do different things with them in different places. So get ready to work on some practice.